correlation between, obviously, VO2 max and the speed reached at the end of the 315, we call VIFT, which was the main objective. But also, there are some correlation with 10 meter sprint times, some correlation with CMG, some correlations with an index of heart rate recovery, for example, and even so with the repeated sprintability. So in that case, that really shows that the running speed at the end of the test is kind of a compound measure, not only of aerobic fitness, but also a compound of the neuromuscular profile and qualities of the players, which obviously makes it way more specific to team sport in overall, but more importantly, more specific to the way we train, the way we implement those short intervals with turns. And to go a bit further on how the 3015 is actually impacted by the other variables than just VO2 max, for example. If you look at the top bottom, that's the typical assessment attainment of VO2 max on the top of the slide. If you look in the bottom, that's the effect of an improvement in maximal sprinting speed, so an improvement of the anaerobic speed reserve, and how an improvement of the anaerobic speed reserve relates or allows the player to reach one or two more stages in the test. Because in that case, improving his maximal sprinting speed will give him more room into this supramaximal zone, and in the end, that will allow him to go faster on the test and make two more stages. Similarly, in this context, if you look at the bottom side of the graph, that will be the effect of a poor running economy, or let's say a player that just puts on weight, it will struggle to turns at the end of each runs, and just because of that, his running economy when turning will actually decrease, and that will make him end up the test way sooner because of this reduced running economy. So again, that's the idea, is that the speed at the end of the test is obviously related to VO2 max, but in addition to that, changes in aerobic speed reserve, changing in chain of direction ability can affect as well the final speed that is reached. So again, that shows the sensitivity of the test to those different factors, and that will obviously confirm its interest for programming intervals, for example. How does VIFT relate to the continuum of the locomotor profile? So most of the time, as I was alluding, the VIFT is more or less 20 to 25% above VO2 max, which means that it's likely the top end reference when we implement high intensity short intervals, as I've shown by the blue arrow. Sprint interval training will be performed obviously way faster, close to maximal sprinting speed. Same as repeated sprints, they are performed above all those velocities, so close to maximum. But short intervals will be performed between 100 and 90% of VIFT. Long intervals, however, will be performed rather close to VO2 max. Since long intervals are still considered as maximal, but not supramaximal types of intervals. So just to finish this part, I'll show you some very simple examples on how the use of the 3015 has helped me to program intervals in athletes that I coach more than 15 years ago at the moment. So these are examples of three handball players I worked with back in the days, so they were professional at that time. So on purpose, we have on one side, we have a player with a clear aerobic profile, so kind of a more slow type of player, tall, so a good engine, but not very explosive as well. In the middle, we have a proper mixed profile, so he has a good aerobic profile, but he also has an anaerobic profile and good explosive capacities. On the right side, I have really the other end of the spectrum. We have a player with a pure anaerobic profile, so not a very high VO2 max, but clearly some very good qualities in terms of jumping and sprinting side. So he's very good at jumping and changing direction. So how do they perform if we do a simple continuous running test? The aerobic type of guy will end up at 18 km per hour. The mixed guy will end up at 18.5. My anaerobic guy, poor VO2 max, will end up at 15. So again, not expected given their VO2 max. How those guys now perform on the 30-15? Obviously, they all go faster, and the best performer is without surprise the guy with the mixed profile, because he gets a bit of all the different qualities to perform better on the test. But what is of interest is the actual improvement in between the continuous linear test and the 30-15. The improvement is about 2 kilometers for the aerobic guy, 2.5 for the guy with the mixed profile, and the guy with the anaerobic profile got actually an improvement in 4.5 kilometers compared with the initial linear and continuous test. And this is likely related to the beneficial effects or the beneficial aspect of his very, very good anaerobic capacities that just help him to go further on that test. And because of this anaerobic quality, he's in the end almost matching the overall performance of the two others, but he's just compensating his lack of pure aerobic fitness with his anaerobic capacities. And that matters a lot to me in terms of training prescription. If we look at what was happening, or if we look at their heart rate response when we use the two types of tests. If we use, as seen on the bottom left, the VO2 max as a reference speed for a 15-15, for example, the response will be quite heterogeneous. In that case, even though we're using 120% of each player's VO2 max, as you can see, player A, the aerobic type of guy, was actually struggling. You could see that his heart rate was on top to the roof almost immediately, and he couldn't even finish the session. In that case, the session was requiring a lot of change in direction, and that was too difficult for him, even though we're using, again, as I said, 120% of each. But this test was done continuously and linearly. So when I had them performed intermittently with COD, there was kind of a mismatch between the way we tested them and the way we trained them. So the guy with the aerobic profile dropped out. The guy with the mixed profile showed more or less the type of curve that we expected. So kind of a slower response because he was still not dying completely, and then he did the 8-minute session. But then again, when you look at the response of player C, the guy with the anaerobic profile, you could see that in terms of his aerobic demand assessed through heart rate, the session was way too easy in that case. And that's related to the fact that even though he was struggling to run continuously, linearly, as soon as we asked him to perform intermittently with change direction, he could benefit from his anaerobic muscular capacity, so that kind of decrease in his energetic cost, and the session became pretty easy for him. So that was the problem I had, and a real problem that I had to experience myself when I was coaching those guys, when I was using the initial continuous and linear test. When I changed now the testing methods, and I've been using the results of the 30-15 for all of them, and using, in that case, 95% of the speed reached at the 30-15, obviously the percentage have to be decreased a little bit because of the difference of the speed, as I said, 30-15 being 20 to 25% faster than VO2 max. We had to change the percentage used, but what's important is now when we use 85% of their own VIFT of each, as you can see, the heart rate response are perfectly matched. So in that case, we manage now to bring them more or less at the same cardiovascular strength, at the same level of training intensity while using the 30-15. So I guess, and I hope that this example shows you really the interest of using the 30-15 for prescription when it comes to prescribe supramaximal intermittent exercises with change of direction. That's really the idea. And so trying to kind of summarize the interest of the 3015 in comparison with other tests. I've just summarized the overall advantages of the mostly used tests. So as you can see, on the top of the figure, we have the yo-yo tests, which are mainly used in the field, but for different reasons that I just can't find really the time, and I want to go deeper into this lesson, which is pretty long already. But for many reasons, the yo-yo is, even though it's a pretty good test to evaluate physical capacity, it might not be as practical and suited for prescription than the 3015. And there are many papers available on my website as well if you want to go further into those details. The UMTT or the University Memorial Track test, this kind of continuous linear tests are obviously not well suited for prescription when it comes to implement and program those high intensity short intervals for all the points that we just discussed. And obviously 3015 represents today to me, and looking at all the people around the world using it, it probably becomes a reality that is very well appropriate to program high intensity interval training in this context. Okay, and when we come back now to our 12 variables that we use to tailor HIIT formats, obviously we won't spend as much time as we spend on programming the intensity, because that, again, as I said, that's probably the most critical aspects. Then we're going to just discuss a few of or the others variables and how they affect exercise tolerance and overall physiological response. For example, if we look at the effect of exercise bout duration, or in that case, or intensity as well, I'd like to have an idea of the ability of the exercise of the body to repeat and keep on exercising, a bit as a battery full of energy, which represents the kind of the aerobic capacity sometimes when it comes to using energy during the intervals and then recovering during the rest period. So if you look at the first example on the top of the figure, with an appropriate duration of exercise and rest, this overall exercise capacity can be refilled during the recovery period. So when there's a good combination of exercise intensity, duration, rest intensity, rest duration, the battery is almost can stay more or less full at the end of the set, because the recovery allows the battery to get refilled. But if for any reason, as in the middle graph, we increase the intensity of the exercise, the rate at which the exercise capacity will be depleted will be increased, and that will actually lead to a progressive decrease of this battery capacity, so that when the set is over, the battery is almost empty. That can be done, as we discussed, with an increase in intensity. We have more or less the same effect if we increase the duration of the interval. In that case, a longer interval would deplete more the energy available in the battery, and in that case the recovery won't be enough for the battery to refill, and that will also lead to a progressive